Okay, class, today we are going to talk about polynomials. Okay, so we're going to review polynomials, R3. And so here we're going to also talk about, to start with, the rule of exponents. So we're going to recall that the notation a to the mth power, where m is a positive integer and a is a real number, means that a appears as a factor m times. Okay, so we're going to multiply a m times. Okay. In the same way, a to the n, where n is a positive integer, means that a appears as a factor n times. Okay, so let's review rules of exponents. So for all positive integers m and n, and real numbers a and b, the following rules hold. So the product rule. The product rule says that if I have two exponentials with the same base, and I'm multiplying them, then I add the exponents. Okay, so again, they have to have the same base. Okay, so if you're multiplying exponentials of the same base, you always add the exponents. And you can see that this is true by looking at this example. Okay, and all you're using is the properties of multiplication. Okay, and the next rule is the power rule. Now the power rule is you take an exponential and you're raising it to another power. So it's a power raised to a power. And so if you have this situation, then you multiply exponents. Okay, so that's the power rule, the first power rule. Okay, and here's an example of where it works. Okay, so again, you're taking the inside, which is a power, and you're raising it to a power, which is the same as just taking this, in this example, and multiplying it by itself 3 times. So it's 4 to the 5th times 4 to the 5th times 4 to the 5th. And of course, if you use the product rule, right, up here, now you're applying the product rule here. Well, the product rule says you add the exponents. So it's 5 plus 5 plus 5, or the same as 5 times 3, which is 4 to the 15th. Okay, and then the second power rule is more of a distribution rule, because if you have a product inside here raised to a power, so you have a times b raised to a power, this product rule, the second product rule, says that you can distribute the power to each factor. So you can write it as a to the m times b to the m. And of course, here's an example of where it works. Okay. And then the third power rule says you could do the same thing with a quotient. So this is with a product. Here we have a quotient, and you can distribute to each of the numerator and denominator. Of course, b can't be equal to 0 because we can't have 0 in the denominator. Now in this example here it says simplify each of the expressions. Each expression we want to simplify using these rules. Well, here we have y to the 4th times y to the 7th. So we're going to use the product rule here. So we're going to add the exponents. And so this becomes y to the 11th. Here we're going to use the product rule, right? Okay. And we're going to use the distributive rule. Okay. So this is going to be 6 to the 5th, 9 to the 3rd, and 2 to the 2nd. Okay. And this is e to the 5th, and so we're going to end up adding these together, okay, because we're going to use the distributive property, the power property, and the product rule. Okay. So if you see here, you distribute, right? Oh, I'm sorry. The 5 is not on the outside. So we distribute here. So we're going to use the commutative law. We're going to put the 6, 9, and 2 together, and we get this, and we're going to put these together. But since these have the same base, we can use the product rule, and we get z to the 5th, 5 plus 3 plus 2, which gives us 10. So we get 108 times z to the 10th power. Okay, so now, what about this one? Well, here we're going to use the distributive property. So we're going to take the powers and multiply them. And so we get 5 to the 6th power. Okay. Here, we're going to use the distributive property. And so we're going to distribute the 3 to the 4 and the 2, and we're going to multiply. Okay, so we're getting 3 to the 4th raised to the 3rd power, or like here. Okay, so we're going to distribute the 3. We're going to get this times this. And then what we're going to do is we're going to use the other power rule, and we're going to multiply these exponents here. So we get 3 to the 12th times x to the 6th. Okay. And then the last one, we're going to use the third power rule. And we're going to distribute the 5 to the numerator and the denominator, like so. And then we're going to use the distributive property on the top and the bottom. And we're going to get, negative 2 to the 5th times m to the 6th to the 5th. Okay, and then we're going to use the other power rule to multiply the exponents. So we get m to the 30th, and negative 2 to the 5th is going to give us negative 32. M to the 30th. On the bottom, we're going to do the same thing. Distribute the exponent. We're going to get 2t to the t squared to the 5th power. And we get z to the 5th, and then of course we're going to use the power rule again here, and we're going to get t to the 10th power. And here we just pull the negative sign out front, and we get our final answer. Okay, now be careful, because this is not the same as this. They're not equivalent expressions, because here we're applying the exponent to both m and n, because we're taking the parentheses, make a huge difference here. And so in this case here we only have m, and n is the only one that has the exponent. Here we can use the distributive property, and both of these get the exponent squared. Okay, because this is the same as this. Okay. Now, a zero exponent is defined as follows. Okay, for any non-zero real number a to the 0 is always equal to 1. Okay, so any non-zero number with a 0 exponent is 1. Okay, so if we use a to the 0 defined to equal 1, we consider this product. So a to the n times a to the 0, which is the same as 1, is going to be a to the n. Because we can use the product rule, and we get the same thing, a to the n. Okay. Now also, 0 to the 0 is undefined. Okay. So the product of a to the n and a to the 0 must be a to the n, and thus a to the 0 is acting like an identity element, 1. Okay. 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 So let's evaluate each power. Well, 4 to the 0, well, since it has a 0 power, this is going to be equal to 1. Here, negative 4 to the 0 power is going to be equal to 1. right? But in this case here, it's going to be negative 1. Okay, or no, actually, this is going to be 1 because it's inside the parentheses. This one, now remember, there's no parentheses here, so the negative sign is outside the power. So this is going to be 1, but it's going to be the opposite of 1, which is going to be negative 1. And then here, this is going to be 1, but then you have negative out here, so this is also going to be negative 1. Okay. And then this here is 7r to the 0 power. So this whole thing is to the 0 power. Okay. So this is also going to be equal to 1, as long as r is not 0, of course. Okay, so now polynomials. If we take the product of a number and one or more variables raised to powers is a term. Okay, so if we take a product, so we're multiplication, so we take a product of a number and one or more variables that are raised to powers, okay, and those powers could be 1, is called a term. Okay, the number in the term is called a coefficient, okay, of the variables that are in the term. Okay, the coefficient of the variable in this expression here is negative 3. And the coefficient in this expression is negative 1. Now, like terms are terms that have the same variables, each raised to the same powers. Okay, so these are all like terms. So they're the same except for the coefficient. Okay, that's the only thing that's different. These are not like terms because they have different variables raised to different exponents. Okay, so a polynomial is a term or a finite number of terms with only positive or 0 integer exponents permitted on the variables. If the terms of a polynomial contain only the variable x, then the polynomial is a polynomial in x. So for example, here are some polynomials. This is a polynomial in x, okay, because we only have x variables. Okay, so these terms are all different, but they're all in terms of x. This is a polynomial in p. This is a polynomial in r. And this is also a polynomial. Okay, these are not polynomial. This is not a polynomial. Okay, because this does not have polynomial of positive or 0 exponents. This has a negative exponent. So in other words, you can write this as 6x to the negative 1 power. Okay, so this is not a polynomial. Now the degree of a term with one variable is the exponent on the variable. That's the degree of the term. Okay. For example, if we look at 2x to the third, there's only one variable and the exponent is 3, so this is a degree of 3. Okay. And the degree of 17x is the exponent on x, which is going to be 1. Okay. The greatest degree of any term in a polynomial is then defined as the degree of the polynomial. So for example, if we look at this polynomial here, we look at the term with the highest exponent. So in this case, it's going to be 3. So this polynomial has a degree of 3. Okay. A non-zero constant such as negative 6 is equivalent to negative 6 to x to the 0. So this has a 0 degree polynomial. Okay. A polynomial can have more than one variable. A term containing more than one variable has a degree equal to the sum of all of the exponents appearing on the variables in the term. For example, if we look at this term, these have different variables with different exponents. So what we do is we add all of the exponents together, and we get what? We get 12. So the degree of the polynomial of this monomial, if you will, is 12. The degree of this one is going to be 7 plus 2 plus 1, which is going to be 10. So the degree of this term here is 10. Okay. Okay, so the degree of a polynomial is in more than one variable is equal to the greatest degree of any term appearing in the polynomial. So again, we take something like this and we add all the exponents for each term, and whichever one is the biggest is the degree of the polynomial. So here this gives us 7, this gives us 6, this gives us 8. So the degree is going to be 8. The degree of the polynomial is going to be 8. Okay? Now, because this term, a polynomial containing exactly 3 terms is called a trinomial. If you have 2 terms, it's called a binomial, and if it's a 1-term polynomial, it's called a monomial. Okay, so let's look at the examples here. So let's identify each of the polynomial as either a polynomial or not a polynomial. If it is a polynomial, then let's identify the type of polynomial it is, whether it's a monomial, binomial, trinomial, or none of these. Okay, so here, first of all, is this a polynomial? Yes, it has positive exponents. Okay, all the exponents on the terms are positive. Okay, so this is a polynomial, and since it has 3 terms, it's a trinomial. Okay, and it's a degree of 7. Okay, here, this is not a polynomial because we have a fraction here. In other words, we have an exponent that is negative, because if we write this as t in the numerator, it's going to be t to the negative second power. Okay, so this is not a polynomial. Okay, can't have a variable in the denominator. Okay, C, this is a polynomial. Okay, because the exponents are all positive. Okay, we don't have any variables in the denominator. Okay, so this would have a degree of 5, and this is a monomial. Now, what about some of the properties that we can do? Well, adding and subtracting polynomials. When we add and subtract polynomials, we have to add and subtract their like terms and simplify as much as possible. So for example, we're adding polynomials, so what we can do is we can drop the parentheses, and since we're talking about adding, we can use the commutative property and put the like terms together. So we put the y to the 4th with the y to the 4th here, so we get 2y to the 4th plus 4y to the 4th, and then we would put y to the 2nd with this y to the 2nd, so we would have negative 3y squared plus 7y squared, and then we put this y with this y. Okay, and so we end up with 6y to the 4th, right, plus 4y squared plus 7y. Okay, and that's what we get. Okay, so notice that we put all of the y's together, and then we used the distributive property to factor out the y, right? The y term, the variable term. Okay, that's essentially what we're doing. When we add like terms, we're putting these terms together, and then we're factoring out the variable part to add the coefficients. Okay, now what about here? So we have negative 3m cubed minus, so we're going to distribute the minus sign first. So we're going to distribute this minus sign. We're going to drop the exponent, or the parentheses, rather. We're going to distribute this negative, because this is like a -1, right? So we're going to change this to, we're going to distribute the negative sign, the subtraction sign. So this is going to be negative, or excuse me, subtract m3. This is going to become a subtraction. This is going to become an addition problem. Okay. And then what we do is we do the same thing. And now what we're going to do is we're going to make this -3m cubed minus m cubed, and so we're going to use the distributive property to factor out the m cubed, and we get -3 minus 1. And we do the same thing for each of the other terms. We get -8, or -8m squared, minus 7m squared, so we get -8 minus 7 times m squared, and we do the same thing for the last one. And then what we do is we simplify. And our final answer is this. Here, we're going to do the same thing. But notice that we've got multiple variables now. Okay, so this is m to the fourth, p to the fifth. So we want to match that one up with this one. And then this term matches up with this term because we have the same variables with the same exponents. So these are like terms. So we're going to match this one up with this one, and we're going to get 8 plus 11 right? Okay, so notice that these are like terms, and we're going to match them up. Oops. And so we get 8 plus 11 is 19, and then we get 9, so -9, plus 15 gives us 6. And that's the final answer. And then for the last one, we've got 4 times this. So the first thing we need to do here is we need to use the distributive property here, and then add like terms. Okay? So notice that we use the distributive property here to distribute the 4, and then we distribute the -5. Okay? So remember, the negative sign goes with the 5, so we're going to distribute the -5. So we get -5 times this, -5 times this, -5 times this. And then we simplify. And we get 4x squared minus 12x plus 28 minus 10x squared plus 40x plus 20. And now we're going to add the like terms. And we get the final answer. Okay. Now, as shown in the following example, A, B, and C, or excuse me, A, B, and D, polynomials in one variable are often written with their terms in descending order. So the degrees, the exponents in descending order, by descending degree. The term of the greatest degree is first. Okay, the one next greatest is next, and so on. So always in decreasing order. Okay, so multiplication. Okay, so multiplication of polynomials. This is where we use the distributive property. Okay, so what we're going to do is, one way to find the two polynomials, such as this, the product between these two polynomials, is to distribute the term, each term of one polynomial across each term of the other polynomial. So for example, we're going to take this term, each term, and distribute across this one. So first we're going to distribute the 3x with this. We're going to take 3x times this whole thing, and then we're going to take 4, the minus 4, and distribute. So we get 3x times the polynomial minus 4 times the polynomial using the distributive property. Okay, so in other words, what we're distributing is we're distributing this polynomial across this subtraction. Essentially, that's what we're doing. Okay, and then we're going to distribute. Then we're going to do the distributive property again, and we're going to take 3x. We're going to distribute 3x across this one, and then we're going to distribute the negative 4 across this one, and we get this. Okay, and then we're going to use the multiplication. Now notice that we're using the commutative property to simplify this. So we're going to do 3 times 2, which is 6, and then x times x squared. Since they have the same base, we add the exponents. We get x cubed. And so this becomes negative minus 9x squared. This becomes 15x. This becomes minus 8x squared. This becomes a positive 12x. And this becomes negative 20, or minus 20. And then we add the like terms, combine like terms, to get our final answer. Okay. Now another method of doing this is to do the product vertically, similar to the method used in arithmetic for multiplying whole numbers. Okay. So what we do is we're going to use this, and we're going to multiply across this. Okay. So if we take 3x, or excuse me, if we take the minus 4 first, so minus 4 times this, just like we would do with whole numbers, by place value. Okay, so we would do 4 times this, plus 4 times this, plus 4 times this, but it's a minus 4. Okay, so we take minus 4 times each one of these, and we get these 3 terms. Okay. Then we go in 1, right? We indent 1, because we're going over 1 place value, if you will, and we're going to do it again. So we do 3x times this, 3x times this, 3x times this, and we get these 3. Okay, again, same thing as what we're doing right here, and then we add down, and notice that we've got everything lined up by the same power, and so we add down to combine like terms, and we get the final answer. Okay, so that's just another way of doing it. You don't have to do it that way, just an alternate method. So here's an example. Okay, so again, we've got 2 trinomials that we want to multiply. Okay, so by doing it vertically, what we're doing is we're taking negative 8 and we're multiplying it by each term to get these 3 terms. And then we're going to take 2p times each of these 3 terms to get these 3 terms, right? And then we're going to take 3 p cubed and multiply by each of these terms to get these 3 terms. And notice how we're lining everything up by the degree. So then we can just add down and combine like terms. And so our final answer becomes this. Okay? Again, this is just one way of doing it. Now, the FOIL method is a convenient way to find the product of 2 binomials. Okay? So for the memory, FOIL stands for first. So you multiply the first terms, then you multiply the outside terms, then you multiply the inside terms, and then you multiply the last terms. So it's always FOIL, which is first, outer, inner, and last. And then you simplify. So if we were going to use the FOIL method here, we would do the first one, so we would multiply 6m by 4m, so that'll give us 24m squared. And then we multiply the inside, or the outside ones, which is 6m times negative 3, which is going to give us a negative 18m. Then we do the inside terms, which is going to give us 4m. And then we do the last, which is going to be negative 3. And then we put them together and simplify. Okay, so this is what we did here. And then you simplify by combining like terms, right? So here we have two middle terms that are the same combined. So we're going to combine them and we get negative 14m, and this is our final answer. Okay, and we can do the same thing for each one of these. Just use the FOIL method. Okay, but the distributive property will also work. In fact, the FOIL method is the distributive property done twice. Okay, so again, it's just a neat way of remembering how to multiply two binomials. But in essence, it's using the distributive property twice. Okay. Okay, and so here's the way you do the other ones. So here we're going to do the first, right? That gives us 4x squared times the outer, which gives us negative 14x. Then we do the inner ones, which gives us positive 14x. And then we do the last ones, which gives us negative or minus 49. And if you combine like terms, you see that the middle terms disappear. They cancel each other out. And we end up with this. Okay? And then, of course, here we're going to multiply these two, so we're going to ignore the r squared for a moment and then use the FOIL method to combine these, to multiply these together. And so we get the first is 9r squared, then the outer, which gives us negative 6r minus 6r, then the inner gives us positive 6r, and then this gives us a minus 4. And then, of course, these are going to cancel each other out, and we get r squared times 9r squared minus 4, and then we use the distributive property and we get the final answer. Okay. Now, if you look here in 7a, what we started out with here, go back, we ended up with a trinomial. Why? Because we combined the middle two terms and we ended up with, instead of 4 terms, we ended up with 3 terms. Okay, but in parts B and C, we ended up with a binomial product. Okay, so the product of two binomials where we have the same terms. Notice how these two are almost exactly the same, except they have opposite signs. Okay, whenever you have two binomials that you're multiplying that have the forms x plus y and x minus y, we get a special product called a difference of squares. Because if you notice, this term is the quantity 3r raised to the second power, or 3r squared, I should say, raised to the second power. This is also a perfect square. This is the same as 2r raised to the second power. Okay, this is where we get the idea of the difference of two squares. Okay, so here are the special products that you're going to want to remember. Okay, so special products, so the products of sums and differences of two terms. Okay, so if we have something like this, it's always going to be of this form, a difference of squares. Okay, if we have the square of a binomial, for example, x plus y quantity squared, okay, that's always going to give us the form x squared times 2x or plus 2xy plus y squared. If it's the difference of two values and we're taking the square of it, then we're going to get this something similar, but we get a negative sign here. Okay, so again, anything of this form will give us this. Anything of this form will give us this. If it's anything of this form, will give us what's the difference of two squares. Okay, so we'll either get the difference of two squares, or if we have something like these two, we're going to get perfect square trinomials. Okay. Okay, and again, if you can get the same thing by using the FOIL method here, because we can treat these as x plus y, the quantity x plus y, times the quantity x plus y by using the definition of an exponent. And then we could either use the FOIL method to get the same answer. But these come up very often that we can just make sure you know these forms, and then you can go right to the answer without having to do the work. So for example, look at this. So we have 3p plus 11, and then we have 3p minus 11. So we know this is going to be a difference of two squares. So it's going to be what? 9p squared minus 121. Now we can get the same answer by using the FOIL method. But if you know the form, then you can go right to the answer. Okay? So if you know it has the same but opposite signs, you know it's going to be of this form, this squared minus this squared. And then you just simplify. Okay? Same thing here, right? So we have this minus this, and then we have the same thing plus the same thing. So all it means is that we're going to take this term and square it, and we're going to take this term and square it, and then take the difference. Like so. And so now we're going to raise this and simplify. So what do we get? We get this. 25 m to the 6th power minus 9. Okay. Now, same thing here. We've got the same thing. So again, all we're going to do is use the difference of two squares. So it's going to be 9k quantity squared, and it's going to be 11r cubed quantity squared, and we're going to take the difference of those two and then simplify. Like so. Okay. Now, here we want to just be careful when we're applying the rules. Okay. This is going to be a product rule, a power rule. So we're going to multiply these. Okay. So this is going to be 11 squared, because we're going to do, this is 11 raised to the 1 power of 1. So it's going to be 1 times 2 is 2, which is 121. 11 squared is 121. And then 3 times 2 is 6. Okay, so remember, don't make the mistake and add these. You have to multiply them. Okay, so this is going to be 9 squared, which is 81, and this is going to be k squared. And so now we're done. Okay, now the last two, we're going to use the sum. So here, it's going to be the first term, then we're going to multiply the two terms together, and then multiply by 2. We're going to double the product of the two terms, and then we're going to add on the last term. So notice that we're going to take the first term squared and the last term squared, and then we're going to take the product of the two terms and double it. Okay, so this is the form. So it's going to be 2m squared plus 2 times the product of the two terms plus the last term squared, and then we're going to multiply and simplify. Okay, and we get 4m squared plus 20m plus 25. Same thing here, but the only difference is the first two terms is going to be connected by a subtraction. Okay, notice these are both addition, right? We're both adding. The difference is this first term is going to be, the first two terms is going to be a minus sign. Okay, so we're going to square the first term. We're going to take double the product of the two terms together, like so, and then we're going to square the last term. But this is going to be a subtraction, and then we simplify, and we're done. Okay, now in example 8D and E, the square of a binomial has 3 terms. Okay, do not give this as a result of expanding this. Okay? You have to be able to combine like terms. Okay? So you can't just leave it as expanded form. Okay? So this is equal to this. This will equal this. Okay? So remember to add the middle term. Okay, so now here's another example. Okay, so we're going to find each product. Okay, now again, you just got to be careful with these. So here's one term in parentheses, and it's the same as this one. So 3p minus 2 is the same. So we can look at this as like one term, quote unquote term, okay, in a binomial, right? And notice that this is the same as this. This is the same as this, except you've got a plus and minus. So this is going to have the form of a difference of two squares. So it's going to be this whole thing squared minus this whole thing squared. So all you have to do is pick out your x and your y. So this is x and this is y. So it's x plus y times x minus y. So you can use a difference of two squares. So it's going to be this squared minus this squared. And now we can use the form for the square of a subtraction. So now we can use the other form that tells us this is going to be this squared minus the product of these two doubled, right, which gives us 12 minus 12p, right, because it's going to be negative 6p, and then we're going to double it to 12p, so we get minus 12p, and then we're going to square the last term, which gives us positive 4. So that gives us this piece, and then we're going to simplify this, and it gives us minus 25q squared. Now, we have to remember to combine like terms. So we have to combine this one with this one. Or no, I'm sorry, these are not like terms. This is q and this is p. Never mind, I looked at it wrong. So this cannot be simplified any further. Okay? Okay, now, what about this one? Okay, well, in this case, we're going to split this up into two. So this one we know what this is going to look like, right? So we can split this up into two factors. So x plus y squared times x plus y. And so now we can expand this using what we know. So this is going to be x squared plus 2xy plus y squared times this. And then we can use the distributive property. Okay? And we can multiply these two terms using the distributive property. So this is going to be x times this whole thing, which would give us x cubed plus 2x squared y plus xy squared. And then we're going to distribute the y and multiply each term by y. And we get the next three, which is going to be x squared y, or xy squared. And then we're going to get xy, hold on a second. No, yx squared. Then we're going to get xy squared. And then we're going to get y cubed. And so we get these three terms. And so then now we simplify this by looking for like terms. Okay, so we get x squared y, and we get another x squared y, so we can combine these two. And then we get xy squared and another xy squared, so we can combine these two terms, and we get this. So we're done. And the last one, we have to the fourth, so we can split this up into two factors that are both squared, like so. And we can use what we know about the square of a binomial. So we can use this here to get this trinomial. We can then use this to get the same trinomial, right? Now we've got two trinomials that we're multiplying, and so we're going to have to use the distributive property to multiply them together. And so you just have to be careful when you're doing this. So you're going to distribute each term across the other trinomial. So the first thing you would do is multiply this term across each one of these three, and that will give you these three terms. Then you take the middle term and distribute it across this trinomial, and then you'll get these three terms. And then you take the last one and distribute it across this trinomial, and you get the last three terms. So you're going to end up with 9 terms that you'll have to combine like terms, okay, and simplify. So if you combine like terms, you get the following answer, okay? Now, again, there's always try these exercises for practice, okay? And if you get stuck anywhere, bring these up in class and we can work them through class. If you don't understand something or you get lost, or if you try these 3 problems and you get stuck, we can work them out in class. This is part of what the flipped classroom is about, okay? Now, division of polynomials is going to be different than what we've been doing with multiplying polynomials, but it is very similar to what we do with dividing whole numbers. Okay, so we're going to use a division algorithm, just very similar to what we use when we're dividing whole numbers. Okay, so let's divide these 2 polynomials. Okay, we're going to divide this polynomial by this polynomial. And so what we're going to do is we're going to set it up like a long division problem. Okay, so we're going to, since we're dividing this by this is the divisor and this is the dividend. Okay, so we're going to divide this into this. Okay, or in other words, we're dividing this polynomial by this polynomial. And so what we do is we say, okay, what do we need to have, okay, to divide? Okay, well, we need to have, well, what do we need to divide by, or what do we need to multiply by in order to get the same thing to subtract? Okay, well, in order to get 4m cubed, what do we need to multiply 2m by to get 4m cubed? Well, that's going to be 2m squared. So if we have 2m squared here, and we multiply by 2m, we're going to get this. So that's what we're going to start with. Okay? Or in other words, 4m cubed divided by 2m gives us 2m squared. Okay? Very much like the division algorithm. So 2m times this gives us 4m squared. And then we multiply -1 times this to give us minus 2m squared. And so now we subtract. So we subtract this entire thing from this. Well, this is going to cancel, and then this is going to become a minus 8m squared plus 2m squared, which is going to give us a minus 6m squared, and then we drop down the next term, which is 5m. And we start the whole process over. Now we say, okay, what do we need to multiply 2m by to get this one? Or in other words, negative 6m squared divided by 2m gives us what? Well, that's going to give us what? 2m squared. So then we multiply. 2m times 2m squared gives us 6. Hold on a second. Oh, I'm sorry, this one. 3m squared. So 2m times a minus 3m gives us a minus 6m squared. Then we take a -1 times minus 3m, which gives us plus 3m. And now we're going to subtract. So we subtract this entire thing, and these go away, and this becomes 2m. And then we drop down the last term. And we do the process one more time. And so how do we get 2m? Well, we multiply by 1. So 2m times 1 is 2m. -1 times 1 is -1. And then we subtract. And we get what? 7. And since we're done, we reach the end, we're done. This is the remainder. This is our quotient. So this polynomial divided by this polynomial will give us this quotient plus this remainder. And so this division is equal to our quotient plus the remainder divided by the divisor. So this is one of the forms that we can put it in. Okay, so that's our answer. Okay, so this number, this division problem, is equal to this plus this. Now, when a polynomial has a missing term, we allow for that term to be inserted by another term with a zero coefficient as a placeholder. Okay, so this can be written as this. And all we're doing is we're putting a zero coefficient in there as a placeholder. Okay, and this helps us make sure that we don't make mistakes when we're doing the long division. Now, in reality, we could get away with not having this with long division, but when we get to synthetic division, we must have the placeholder. So it's good to get into the practice of having this placeholder in here. So if we want to divide these two polynomials, we're going to end up having a placeholder in both of them. Okay. So we're going to rewrite this with a zero coefficient here, or a zero term and a zero term here. Okay. And then we're going to do the same process. So now what we're going to do is we're going to say, okay, we want x squared. Okay. So in this case here, how do we get a 3x cubed? Well, we're going to have to multiply by what? A 3x. So there's where the 3x goes. And the 3x goes over the x terms, right? So then we do x squared times 3x gives us 3x cubed. 0x times 3x gives us 0x squared. And then negative 4 times 3x gives us a minus 12x. And so now that we've got all these, we now subtract. So we subtract this whole thing. And remember, you've got to subtract the whole thing, which means this is going to become a negative x cubed. This is going to become minus 0x. This is going to become plus 12x. So this becomes a minus x squared. This becomes a plus 12x. And then we take the 150 and we drop down. We do it one more time. And we get, well, in order to get negative 2x squared, we're going to have to multiply by a minus 2. And we do the same thing. And we get these three terms. And then we subtract. So this is going to go away. This is going to become 12x. And this is going to become a negative 158, or a minus 158. And this becomes the remainder since we've reached the end. Okay, we're done. So this is our remainder. This is our quotient. And so this divided by this equals this plus our remainder divided by this. And so here's our answer. Okay, now you can go ahead and try exercise 103. And we're done. So these are the exercises. So make sure you do these exercises as practice. Do the homework. And again, if you get stuck on anything, bring those problems to class. Or if you didn't understand how to do any of these examples, ask about them in class, and I'll be more than happy to go over them again. So again, until next time, practice, and I'll see you later.